Hey everyone, Dave here. So today I want to carry on with the NEP-5 series and I want to implement the BalanceOf method from the NEP-5 standard. So the BalanceOf method is going to get the balance of anyone's account. Now, the first thing we're going to need though is to get funds into someone's account. So we've said that we've got a total supply of 1,000 tokens. But we don't give those tokens to anyone when our contract starts up here. So what we're going to do is we're going to create a method here called initialize. And what this method is going to do is it is going to give the tokens to someone when we first start it. So we're going to run this method once. We're going to give those tokens to someone, and from there on, then that person can transfer them out of their accounts and things like that once we implement the transfer method, of course. Now, this method doesn't have to be called initialize. It can be called anything you want. This isn't part of the NEP-5 standard at all. You could call it kittens. So what we're going to need to do here is use the storage method. So storage is actually part of this, this namespace, Framework Services Neo. And we're going to do a storage.put. And then the first parameter this is going to take is the context. So the context here is our current context or our current contract. It is possible, I've been told, to access another contract storage. So what you could do is if you wrote one contract and had a bunch of data amassed inside of it, you could write another contract and pull the data out of that contract by using its context. I've never done this. I've never seen it done, but that is the purpose of this method here. So the next thing this takes is a key. So I'm going to call this Dave's balance, and it's going to take a value. So I'm going to return, or I'm going to put in there the value of our entire supply. So now I've got a balance in there, and you know what, let's write the get balance as well, or the start of it anyways. Balance of, just so you can see the other side of the storage. So again, we've got to pass in the context. And that should be it here. So we built that. We'll bring up the debugger here, and what I'm going to do is I'm going to reset, or sorry, blockchain reset, just to wipe out any storage, anything we have. So this resets everything back to kind of an initial state. So if we look at storage, it says please deploy the contract first because we haven't done anything here. So we're going to run this, and we're going to go initialize first. It doesn't need any arguments. I'm going to leave this in here because we're going to use this pretty shortly. It's just going to ignore them. So execution finished, the gas cost, the instruction count. If we look at storage, we see nothing for some reason. Maybe let's step through it here and see why that happened. So I'm just stepping through with F10 here. It's because I spelled initialize wrong. That would do it. So let's just go fix this up here. It is early morning here, so maybe I will make some mistakes. Add a little more of this. build. Just back up here. At least it still has initialize in there. And then if I look at storage, there, now there's a key of Dave's balance with the content of our 1,000 tokens. And now if I run BalanceOf, why did that not work? BalanceOf, yeah. Again, we'll step through it. Good example of using the debugger. Oh, I didn't return it. Yep, first thing in the morning. So that's going to get the bounds, but you will notice here that, of course, the key is hard-coded. So one of the things that surprised me with how NEP-5 works, or any token, is that what it's actually doing here is it's keeping track of everyone's balance by basically treating the blockchain as its database and updating the data. So we'll actually change, if we were to transfer money, we load this Dave's balance key and change the value. So we decrement from one person's account, add to another person's account, and then just save the value of those, that key and value to the blockchain. Instead of it being, you know, like how NEO and gas work as like unspent transaction outputs and moving those kind of things around, and you know, it's much more complicated the way the blockchain works, I guess. And this is kind of a nice way to do it, but it surprised me that this is just basically kind of database work. So let's fire this up here. So here we got back that A08601, and I said that I would show you a tool, and I will do that here. So I like this SCADA core website for this, A08601. So the nice thing is that this will convert that hex data and bring it back in multiple different formats. So here it is in ASCII, obviously not very, very important. But you'll see here in the int32 little endian, we get the value that we expect here. So it's one of the things to note is that the endianness is important. If you've never dealt with endianness, I'll give you a quick little rundown here. So here's a 32-bit integer. 0A, 0B, 0C, 0D. As a big endian, the most significant digit is stored in the first spot. So 0A goes into the first spot, 0B in the second, 0C in the third, yada yada. For a little endian, we have the same 32-bit integer, but you'll notice that 0A is actually stored in the last spot, then the next spot up, then the next spot up, and then the least significant digit here, the last bit of our 32-bit integer, the 0D, is stored in the first spot. So different architectures will use different endianness. I believe like your typical like x86 processor is going to use big endian, but protocols like I believe TCP will use little endian. Could be wrong on that, but or maybe I've got them backwards. So lots of communication protocols I know use little endian, whereas some architecture uses big. It's an arbitrary choice of developers and engineers, but once you've picked one, you gotta kind of stick with it as that evolves. So sometimes you'll have these incompatibilities between systems. I know I've run into this a few times dealing with some microcontrollers and things like that, where it's returning it in a different endianness than I expect. So that's what that is. You can see here if we transform it as a big endian, we get a very different number versus a little endian. So, and I think most online hex converters will use big endian. That's why I like this one here. Another thing to note is that this hex string is only going to be translatable on here for small numbers. That's why I used a 1,000 in our example. If we used 1,000,000, it's going to come out with something very different because it's outside of the int32 space, and that's where the big integer works in C#. So there's going to be some stuff in there that kind of happens. So if you want to transform big numbers, you're probably going to have to write a little utility of your own. Maybe there's another one out there that we'll discover later on. Okay, so now to try and wrap this up a little bit here, we've got Dave's balance here. That's not what we want, though. We don't want to store Dave's balance, Joe's balance, Kim's balance. We want to store this per Neo address. So I'm going to use this string here. I copied and pasted that for speed here. Public static read-only byte owner equals this. So this is, you may recognize this address if you set up a private net. This is the address that has all of the Neo and gas, right? And then I'm calling this extension method to script hash. So this is going to convert this address from this human readable format to its script hash format, and that's kind of what everything uses internally is the script hash format. But this is the human readable format that you're probably used to. So I've got that. That's a byte array. I really want to hammer on this though. This static read-only bit here. I have been bitten so many times by forgetting to put this in as a static read-only. And the code will compile fine and everything will work fine, and you try and use it and it doesn't behave like you expect it to. This is just something with how things get transformed from your source code into the MSIL and your DLL, then into the NeoVM bytecode. There's something that just goes awry. So if you have weird things accessing this variable, this global variable, make sure it's a static read-only variable. Okay, I'll stop hammering on that. So now what we're going to use, instead of Dave's balance here as the key, we're going to use the owner. Right? So we're going to use the script hash of me as that balance. And then here, we don't want to hard code in owner because we want to be able to check anyone's balance. So what we're going to use is these args that get passed in, and we're going to say the first arg passed in is a byte of, args bracket 0. So the first parameter, we're casting to a byte array, and we'll get that balance. So if we rebuild this solution, we are going to be able to run this now. So the first thing I'm going to do is I'm going to call initialize. Now, as I said, this argument is ignored. It's not used in this call. Now I want to look at the storage in the blockchain here. Did I run this right? Man, I'm forgetting that second I a lot. So now you'll see here that we've got Dave's balance from our first run here in storage, and then this key and the same amount here. This is because I didn't reset the chain. So anything that's in there existing just stays there. So I can always reset it and do a blockchain reset. And actually I will here just because I want a clean start. So I'm going to do balance of, actually I realized I've got a different address in here from something I was testing earlier, but this is a good test here. It should return, oh yeah, it does return null for that. let's go and grab that address here. So instead of this other address I was mucking about with, there. So it returned back now the balance of this account, and you saw when I did the other address, it returned back null. There. So one thing we should look at here before we end this video is back at the proposal, the balance of method. So it says the parameter account should be a 20-byte address. If not, this method should throw an exception. So we should do a little input validation here. So actually I'm going to, why am I doing this in the debugger here? Let's do it in Visual Studio. So you can actually add a code in the debugger too. I just prefer Visual Studio. If address.length is not equal to 20, I don't believe that this message, this invalid address, ever actually would bubble up to anyone. It's just the Neo VM will catch this and fail and say that the application did not run properly. I like just to put these in here just so I can see that why I'm throwing this exception and what it would be. Also, if you're writing unit tests against this, it's nice to kind of catch things as a specific exception too. So let's build this. Okay, let's bring up the So I'm going to change this. I'm going to kill a digit off of there, which will make it an invalid address. So it says execution failed, which is exactly what we want. And it's nice that it actually launches us into here and says, okay, well, it failed around this line. You know, it did actually fail here, but as you know, kind of with exceptions, they'll fail in interesting places. So that's that. The nice thing with this too is the NEP-5 says that if an account is an unused address, the method must return 0. So by default, because this is returning back an empty byte array, that's going to translate to 0. Yeah, I know the debugger said that the result was null. It's always going to show as null even if you return a 0 from here. The main thing is that if the address doesn't exist, not to throw an exception, I would say. So that's what I wanted to cover here. We've covered initialization of our contract, and we've covered the balance of. Next, we'll get into a little bit more of a security check around initialize, and hopefully start on transfer. So I will see you in the next video. Thanks, everyone.